So in our last lesson, we talked about systems of equations and what it means graphically to find a solution, which was where points of intersection were the common solution in each equation in the system. And then we talked about how to use substitution, where we'd solve for one of the variables and then plug it in. And today we're talking about a different method of solving, which is elimination. And then we're going to look at some application problems, which usually means word problems. And in this case, it definitely means word problems. So I like these worksheets that I've been using to break it up, because it does list these steps for us. And the first step in this says line up the equations. And that is something you really want to pay attention to when you're doing your delta math, because delta math doesn't line them up for you. So you are going to need a piece of paper and a pencil to be doing your homework for your delta math. Honestly, you should be using pencil and paper for all of your homework, but this one, if you could do it in your head, I would be impressed. And then we're going to find something to multiply each side by to be able to eliminate one of the variables, right? So that they have the same coefficient, but a different sign, so that when we add or subtract them from each other, one of the variables will disappear, and then we can solve for one variable. Solve for the remaining variable, and then substitute your answer from step 4 into the original equation to find the other variable. Now, I know that's a lot of words until you actually see it in practice. So we're going to go ahead and we're going to look at these problems and try and figure out how to solve them, right? They are already lined up for us in these sheets, so we don't even have to think about lining it up right now. But what we need to do is look at this and go, well, what can I do to drop one of these variables out? Now, if I look at this equation right here, I have an x here and I have an x here. So if I subtract all of this from here, I really don't have to do anything to this except for subtract the whole thing. And when I say the whole thing, I mean the whole thing, right? I need to subtract each component from the previous component. So what does that look like? That's x minus x. Well, those x's are just going to cancel, right? But this is 7y minus y, which is like saying 7y plus y, which gives me 8y. And then I have 17 minus 7. So that's like saying 17 plus 7, which is going to give me 24, right? Which makes this really easy to solve for the y variable, because right now, what do I have? I have 8y equals 4. So I only have to divide each side by 8 to find out what my y equals. So in this case, I'm going to get y equals 3. So now that I know what my y equals, I can take this equation, the one I didn't play with, and I can write it in. I can go x plus 7y. Well, what is y? Y equals 3. So I'm just going to put in the 3 there where the y would be. Equals 17. And then we can go ahead and solve and find out what x is. So that's saying x plus 21 equals 17. And I can subtract 21 from both sides, and I get x equals 17 minus 21 is negative 4. And so I found my point, right? My point would be negative 4, 3. The best part about this is if I wanted to, I could check, right? I could plug this in. Let's look at the other equation. Do I have to check? No, I'm not going to require you to, but you know if you're right or not. Because I go, okay, well, let's look at this equation. X minus y equals negative 7, right? X minus y equals negative 7. If I plug in for x negative 4, And for y3, it better give me -7. And that totally checks out, right? So if we look at this next problem right here, we don't have to do anything to that again, right? If I just add these two together, I don't have to subtract anything. I can just add these two problems together, and I would wind up with 8x, and this would drop out. 2y minus 2y is just 0, and I'm left with 8x equals 64. And then I can divide by 8 and divide by 8, and I get x. It's supposed to be an x equals 8. And again, I can just plug this in now into the original equation. Doesn't matter which equation I choose, right? I go 3 times 8 plus 2y equals 22. And I get 24 plus 2y equals 22. And I can subtract 24, and I get 2y equals -2. Divide by 2, divide by 2. I get y equals -1. So now I have my x and my y, right? I have an 8 and a -1. That's the weirdest 8 ever. Snowman with his head chopped off. And so those are really simple elimination problems. We didn't really have to do anything. We just basically had to determine, are we going to add or are we going to subtract? But as we move into our other problems, we're going to have to do a little bit more work on them, right? Because if I look at 4x and x, if I'm looking at this problem, I can't just subtract this and have one of them disappear, right? And I can't add or subtract this and have one of the variables disappear because they're not opposites. But I can look at this and go, well, if I multiply this whole thing times -4, that would give me -4x, right? Which is the opposite of 4x. So I'm just going to multiply this whole thing times -4. And I'm going to rewrite the equation. I'm going to rewrite the top equation, which is 4x minus 9y equals -42. And then I'm going to rewrite the bottom equation with the -4 multiplied to it. Now remember, I can't just multiply it to the x here. I have to multiply it to each piece. So -4 times x is just -4x, which is what we were going for. -4 times 5y, well, that's -20y. And -4 times 4 is -16. And now I have the ability to add these equations together and have that x value drop. So if I look at this, 4x minus 4x, well, that's 0. So our x value disappears, right? Now I'm left with -9y minus 20y. Well, that's -29y equals -42 minus 16. So I can add these together. I know it's going to have a negative. It'll be -58. That is convenient. Why is that convenient? Because 29 times 2 equals 58. So if I divide both sides by -29, I get a nice, reasonable answer, right? I get y equals 2, right? And that's the whole idea, is for us to get one variable so we can solve for the other. So I'm going to take this y equals 2, and I'm going to plug it back into this equation. So I've got 4x minus 9y, well, y is just 2, equals -42. So I'm going to solve this. 4x minus 18 equals -42. And so we're going to start taking everything off of the x, right? We're going to solve for the x. And I'll start this by adding 18 to both sides. What is -42 plus 18? Well, I'll tell you, it's negative 24. So I wind up with 4x equals negative 24. And then we can just divide out our 4. It's a 4. Divide out our 4. And we get that x equals negative 6. And so we have our point now, right? We have negative 6, 2 is our point. Can I check it? Absolutely. If I want to, I can plug it into either equation. It should be true for either equation. Am I going to verify it right now? No. 1, because I'm out of space. And 2, because, well, I don't want this video to be 18 hours long. So again, we have an equation set in number 4, right? Where I don't have anything that will just drop out by adding or subtracting, right? I've got 7x and 2x, and I have minus 6y and 3y. So I'm going to look first at, is there anything that I can multiply one of the equations by that will just drop out one of them? And I know that 3 times 2 equals 6. So I can play with this a little bit, right? Sometimes there's nothing and we have to multiply both equations. But I know that 2 times 3 is 6. So if I do something in that realm, I can make my 6 drop out, my y drop out. Now I want it to have an opposite sign. So I'm going to multiply this times negative 2. Right? Because if I do that, that gives me a positive 6y. And so when I add these two equations together, one will drop out. So again, I'm going to rewrite the first equation just so they're stacked. 7x minus 6y equals negative 53. And then I'm going to distribute this negative 2 to each piece. Negative 2 times 2x is negative 4x. Negative 2 times negative 3y is plus 6y. It's our whole reason for being, was to create that opposite. And negative 2 times negative 13 is positive 26. And then we can just add these together, right? And we get, well, we have 7x minus 4x. That's just 3x. Our whole reason for being was that minus 6y plus 6y is 0. So we've eliminated our y's. And then we've got equals minus 53 plus 26 is negative 27, which is convenient because when we divide by 3 on both sides to isolate our x, I know that 27 is evenly divided by 3 and we get negative 9. So we found our x value, very important. Now we need to go back and find our y value. We're going to take this x, and we're going to plug it in here where the x is, and we should be able to find our y. So we've got 7x. So 7 times negative 9 minus 6y equals negative 53. 7 times 9 is 63. This is a negative, so we have minus 63 minus 6y equals minus 53. So I'm going to start by undoing here, and I'm going to add 63 to both sides. I'm going to get minus 6y equals 10. Wow, am I getting a fraction for an answer? Yes, I am. Yes, I am. That's okay. Now I'm going to divide by this negative 6. And these will cancel, right? Because they become 1, and I get y equals, I can't have 10, 6. Each of these are divisible by 2, so I'm going to call this negative 5/3. Now, like I said, I could plug this in to either equation and prove that I am right. But one, I don't have to because I just looked at the answer. And two, I don't really have room to. So we found an XY value that is true to both equations. If we graphed these equations, that is the point where they would intersect. Let's look at maybe one more. I'm trying to see what we've got here. These look more of the same, like what do I multiply by? So I'm going to skip those and move into these because notice these aren't necessarily in order. And our first step was to line up the equations. And if we look at number 7, the top one is in XY order, but the bottom one isn't. So I'm going to start by rewriting the top one as 5x minus 6y equals 3. I need this one in that same order, which means I need to move my x value over to this side. So I'm just going to subtract it. I'm going to go minus 2x, and that's going to give me minus 2x plus 7y equals 8. And now it's in the right order, so I can move it up here, minus 2x plus 7y equals 8. Now we need to look at these problems and go, well, how can I make these line up properly? How can I make one of these variables disappear? And if you notice, I can't multiply 2 times anything to get 5. And I can't multiply 6 times anything to get 7. So I have to pick a variable. I'm going to do my x variable, and I'm going to have to multiply each equation by something to find a common coefficient that'll disappear. So when I want to do that, when I know I have to multiply both of them, I'm going to take the bigger one. In this case, it's 5 because I'm going to do my x's. I'm going to multiply it by 2, and I get 10. And I'll look at it and I go, does 2 go into 10? Yes, it does because I multiplied it by 2. And so I know it'll work for this one. So I can multiply this equation by 2, and I can multiply this equation by 5. And I'll wind up with 10x here and negative 10x here. So I'm going to create my new equation by distributing. I'm going to go 2 times 5x is 10x. 2 times negative 6, make that look more like an x. 2 times negative 6 is negative 12y. 2 times 3, right? I have to do it to each piece of this equation. 2 times 3 equals 6. Now I'm going to do it to the bottom equation. I'm going to go 5 times negative 2 is negative 10x. Whole reason for doing it, right? 5 times 7 is 35y. And 5 times 8 is 40. So now I created these two equations. I haven't changed the values of them. They're just multiples of the other one. If you remember, multiples graph right on top of each other. So it's like having the same equation as I did before. But I created it so that I can add them together and my x values will drop out. Because 10x minus 10x is just 0, right? So I know these are going to drop out on me, right? And so here I'm going to be left with minus 12y plus 35y. So that's going to be 2y. And I get 23y equals 46, which is convenient. Why? Because I know that if I divide this by 23 and divide this by 23, I'm going to have y equals 2. And so I get to take this y equals 2 and plug it in for y in either one of these equations, really, but I chose the top one. Why? I don't know, felt like it. So I have 5x minus 6y. Well, we know what y is. Y is 2. So that's 6 times 2 equals 3. So that gives me 5x minus 12 equals 3. And now we're going to just solve for this x. I'm going to start by adding 12 to both sides. And I get 5x equals 15. Then I'm going to divide by 5 to get that 5 off of the x. And I get x equals 3. And so I know my point now, right? My point where these two intersect will be at 3, 2. I can prove it. I can plug them in, but I'm not going to bother. And that's how these problems are going to work. The next one, same thing. I'm going to have to line them up. I probably won't even solve this whole problem, but I will show you that each problem here needs to be lined up. Here I've got 10x plus 18 minus 8y. Well, equals minus 8y. So I need to switch these places around. I need this 8y to be on the other side. So plus 8y, which gives me 10x plus 8y plus 18 equals 0. And then I need to move that 18 over, minus 18, minus 18. And I get the equation I want, 10x. Let me actually write that properly. $10x plus 8y equals negative 18. So I've got that first equation in the right order. Now this one, I'd have to subtract the 4 from both sides, and I'd get 9x equals 5y minus 4. And then I'd have to subtract the 5y, subtract 5y. And I get 9x minus 5y equals negative 4. And then I can stack these, right? 9x minus 5y equals negative 4. And then I have to start looking at how am I going to eliminate something, right? I'm going to have to find a common multiple, the least common multiple of one of these. Do I have an easy one? No, I don't. The closest one I could find is if I multiply, change color so you could see. If I change this, I multiply this times 5, and I multiply this times 8, we'll cancel out our y's. And I'm going to leave the solving of the rest of that to you because I want to discuss applications with you. And when we're doing applications, we're talking about word problems. Define your variables. What are we solving for? Set up two equations. That's a very important part, right? Using the given information, and then solve the system using your method of choice, which means you can use substitution or you can use elimination. But the trick is to read the words and then to pull the math part out so you can get rid of the words. So here we've got Marcy bought a total of 20 used books and CDs during a yard sale for a total of $54.50. If books cost $1.50 each and CDs cost $5 each, how many of each did she buy? Now, I am going to make my variables equal B and C. B equals books, right? And C equals CDs. Not that anyone buys those anymore. What we know is that B plus C equals 20, right? Because she got a total of 20 used books and CDs, right? So if I add my books and my CDs together, I'm going to get 20, right? I know that every book costs $1.50, right? So $1.50 times B plus CDs cost $5. So 5 times C equals, what do we know? A total of $54.50. So we don't know how many B's we have here, and we don't know how many C's we have here, right? But we know if I multiply it times $1.50, that's the price of each book. And then if I multiply my CDs times 5, that's the price of each CD. What I know is that one book, all of my books, plus all of my CDs equal 20. And so when I look at this, I'm going to go, okay, well, look at this. I have an equation, right? I have set up this linear equation. And in doing so, I can do the same thing that I did before. I can go, okay, well, what can I multiply these by to drop out one of my variables? Well, this is nice. I could multiply it this one times 150, but then I'm dealing with 150. Or I could multiply it times 5. So I'm going to choose to multiply it times 5. And when I do that, my new equation on the top is going to be 5 times B is just 5B. 5 times C is just 5C. And then 5 times 20 is 100. And then my bottom equation is going to stay the same. So I can write it under here as 1.5. What if I did -5? Let's make it -5 instead. Why would I do that? If I multiply it by -5, I'm going to have the C's disappear. Or if I multiply it by +5, then I got to go through and subtract the whole thing. So my bottom equation is going to stay exactly what it was, right? It's going to be 1.50B plus 5C equals 54.50. But now I can just add these together, right? And my C's will drop out, and I'll be able to solve for books. So 150 minus 5, or however you want to look at that, 150 minus 5 is what? 3 minus 350? Well, it helps if I put it in right, but it should be 350, right? Negative 350. These drop out equals -45.50, negative 45.50. And you're probably thinking, well, how do I have a negative price? But you don't, because when we divide this by 3.5 or 3.50, negative 3.50, divide by negative 3.50, we get B equals, sorry, 13, right? Because a negative over negative is a positive. We wind up with B equals 13. And then I can plug it into either equation. And I know that one of my equations is B plus C equals 20. And so if I know that B equals 13 plus C equals 20, it's going to be a really easy solve for me, right? Subtract 13, and I get C equals 7. And so what we've learned is that we sold 13 books and 7 CDs. Now this is getting long, so I'm going to stop it, but I'll probably do some more word problems in class with you guys so you can get a feel for it. But that is it for the video lesson, Edpuzzle. And if you have any questions, let me know. I can always make time for you if you need it. I'll see you in class.